Okay, so 3U Chapter 4 Assignment Question 12. You've got an arrow. I've drawn it here in red. Here's the mass, 0.20 kilograms. At this point right here, what's happening is a human being is pulling the arrow back on the string. The human being is using a force of 110 newtons. How far does a human being pull back on a string? For 0.60 meters. So when it's right here, it's not moving. It's being held by the human. So it's got an initial speed of 0. Well, if the human is applying a force through a displacement on this arrow, that means work's going to be done to it. So eventually the arrow is released and it's going to have a final speed right here when it gets back to the spot where the string doesn't push it anymore. So that work done by the human, all right, it's the work done by the human on this. That work done by the human, it is equal to this equation here, force human dot displacement, which is the magnitude of the force, the magnitude of the displacement times the cosine of the angle between these two vectors. Well, we know the force, we know the displacement. Both of these forces are in the same direction and parallel to each other. Here's the direction of the force, here's the direction of the displacement. They're parallel. That means we've got the theta is 0 degrees. The cosine of theta is 1. So the work done is 66 joules. Now, in this particular case, the work done to the arrow gives it speed, gives it kinetic energy. So work is equal to the change in kinetic energy. When you are equating work and energy, you always have to have the delta in there. It's always going to cause a change in energy. In this particular case, change in kinetic energy. So change in kinetic energy is always, because it's a delta, final minus initial. Final kinetic energy minus initial kinetic energy. And we have here the fact that the initial kinetic energy is 0, because when the arrow is right here, it's not moving, it's being held. So at this point right here, it's got no kinetic energy. Then it's shot forward. All that work that the human done is now being converted into kinetic energy, and it gets to right here, and now it has velocity because it has kinetic energy. And that's what we want to calculate. We want to calculate that final velocity. So we know that it has this amount of kinetic energy final, because this term here is 0, it's gone. So the work is solely kinetic energy final, 66 joules. So let's follow the yellow arrow here. We know the equation for kinetic energy final, half mass times speed squared. So we multiply both sides by 2 to get rid of the half. Then we divide each side by m, and we're left with this equation right here. 2 times kinetic energy final divided by mass is equal to the final speed squared. Now we have to square root both sides. So we square root both sides. Final speed is the root of 2 times kinetic energy final all over the mass. Let me put an F there for final. Now we substitute. So we plug in the numbers, we do all our math, and we get 26 meters per second. So that's part A. Part B, the arrow isn't shot forward, it's shot upward. So all of the work that was done by the human causes the arrow to leave a height initial of 0, go up into the arrow. So the arrow is going to go up into the air and get to its highest point, which we call height final. At that point right there, it's not moving, because when things reach their highest point, they stop for an instant before they fall back down. So here, it's got no kinetic energy. All of the energy that it has right here, all of the energy that it has right here is gravitational potential energy, final. And what we want to find is, what is that height final? How high did the arrow go? Well, in this particular case, work was still done on the arrow. But in this particular case, all the work done when it gets to the very top of its motion is a change in gravitational potential energy, which is gravitational potential energy final minus gravitational potential energy initial. Well, look, it started from a height initial of 0. So it had no gravitational potential energy initial. So all that work went into becoming gravitational potential energy final, which is 66 joules. So now we write down the equation for gravitational potential energy final. It's mg, mass, times the magnitude of the gravitational field strength near the surface of the Earth, times height final. and we rearrange this. We divide both sides by mass and gravitational field strength. So we divide both sides by that, and we get this equation right here. And then we plug in the numbers, and we find height final. That's how high up it got. I hope this helps. If you still have questions, just let me know. Okay, have a great day. Bye.